Hi, all. Welcome back. And today we are going to learn about the part third of relational algebra. That will in here we are going to see about how to calculate the maximum and minimum number of tuples when we are performing the relational algebra operation onto two relations. So let's say we have two relations like R and S, and R has n distinct tuples. Okay, so for R we have n distinct tuples, and let's say S has m distinct tuples. So S has m distinct tuples, right? Now let's perform some relational algebra operations over R and S, and let's see what is the maximum and minimum number of tuples we obtain from there. So we have this RA, and we have this table like min tuples. What are the min tuples, minimum number of tuples and maximum number of tuples from here? And let's see how to obtain this. So yep. Okay. So if we are doing the cross product of R and S, then minimum number of tuples in R and S, uh, and maximum number of tuples in R and S. So let's say that R and S are non-empty. So minimum number of tuples could be n into m, and maximum also n into m at most. Okay. Then we are performing, let's say, another operation. Let's say it is a join operation, and we are performing join as the natural join. And let's say in join, if we don't have any common attribute in RNS, okay, so minimum number of tuples will be 0, but maximum number of tuples could be n into m. Okay, if we are performing the join operation onto R and S, and let's say it is conditional join, then also the minimum number of tuples could be 0, maximum could be n into m. Okay, if we are performing the left outer join from R and S, and then we say the minimum number of tuples, so it could be minimum n, because if there is no common attribute between R and S, so the natural join, we have already seen that if there are no common attributes between R and S, so the natural join is empty, right? uh, or sorry, the natural join is cross product of two relation, that is n into m. But let's say if we are applying certain condition and that condition does not gets accepted, then the minimum number of tuples could be 0. Okay, even in the natural join, if we have n and m tuples, so here if we see, the minimum number of tuples could be 0, because let's say we are applying this natural join, and we have, let's say, uh, minimum number of, let's say, one common attribute between them, or if we don't have any common attribute, then it will be n cross m, right? But if let's say we have something, we are applying the condition something, and that condition fails, so it will be 0, right? Similarly for natural join along with condition outer join of R, so if we have 0 minimum number of tuples for R natural join with S, but we are also including the tuples from R, so minimum can be n, and maximum can be again n into m. For the same R and S, and it is right outer join with S, it could be M, and it could be N cross M. Okay, and then we have something called the outer join. Okay, so if we have outer join, so the minimum number of tuples in our outer join of R and S could be n plus m here, or let's say if we have altogether n elements in R and m elements in S, and let's say we have this we got as 0, no I mean the minimum number of tuples in the natural join is 0, then altogether we can get the maximum of n cross m, and this we can get n into m. Okay, and for the remaining operators, we will be seeing this next, but let me write it here in the formula chart so that it is reminded always. So if we are taking the union of R and S, so union of R and S, maximum minimum number of tuples will be maximum of n and m, and maximum could be n plus m. If we are taking intersection of R and S, then it could be 0, and this could be a minimum of n and m. Okay, and if we are taking minus R and S, then it will be 0, and it will be minimum, maximum could be n. And if we are taking division of R and S, so minimum could be 0, and maximum could be n into m. Okay, so this way we will see about all these four in the upcoming video. So this is about the maximum and minimum tuples that we can obtain in the relational algebra. So I would like to show you some of the examples, a bit of these two. So let's see some examples of minimum and maximum tuples from here. Yep, and let's say we have relation R, and it consists of AB, and we have relation S, and it consists of BC, and B is the common attribute between these two, and this is 2 3 4 5, and this is 2 3 4. So if we are taking the outer join of these two, so if we are taking the outer join, so this is the common attribute, right? And if outer join is there, so based on the common attribute, this part, we altogether have three tuples, that is 2 3 4, and this 5 will come from this outer join. Okay, so this 5 will come here. So altogether we have four tuples into the outer join with R and S, right? So if we say that how many altogether, like 2 3 4 and 5, so if we say the maximum minimum number of tuples, or the maximum number of tuples, so if we are taking the minimum, so minimum, how many tuples could be there? Like there could be more. If in B we can have more, so there could be more, but bare minimum number of tuples will be n, maximum of n and m. Okay, so bare minimum will be maximum of n and m. Now, yeah, so we will see some of the questions based on to that, how to apply these to normal questions. So yeah, that we will be seeing in the upcoming video, and then we will be moving towards the set operators that we have already seen, that is union, minus, intersection, and of course one more is there, that is division. So yeah, that we are going to see next. So that's all from this video. To keep watching, and if you do have any comments or questions, please comment in the comment section.